to our incubator channel, which is Incubator IITK, and you can access the recording there. Yeah, that is all. Over to you, Abhijit.
Cool. So let's get started. Then, as I said, right, AI is not just a buzzword now. It has got into this mainstream business and has penetrated well. It has further proliferated and delivered billions of dollars of value to the businesses. Let's look at some of the recent headlines in the field of AI. Uh, very recent news, just a day ago, right? Now, UK, they are going to use AI to predict the cloud movement so that they can empower or they can boost the solar energy generation using AI. We all know 3 years back, the art that was created by AI was sold at hopping 400K USD at a Christie's. If we look at the other news, which is also very recent, Bosch, one of the large leading manufacturer, is going to use AI to do RCA, the root cause analysis for defective parts. And not just that, many organizations have already started using AI for predictive maintenance. Very recent news again in the field of healthcare, AI has already predicted shapes of molecules to come. And we know the recent breakthrough by DeepMind, which has predicted the structure of the human protein. If you look at the banking sector, AI is not far behind there as well. It has penetrated well. Historically, financial sector was said to be very regulated and very restrictive in terms of adopting to some of the new technologies. But we can see BNY Mellon, along with Google, have developed AI solution to spot the treasury trade fails. Not just that, I think many organizations are using AI fraud detection and prevention. And again, in terms of climate control as well, one of the states in US, California, has employed AI to spot wildfires so that they can prevent the spread of wildfire before it gets to a very concerning stage. If you look at the value that AI is generated, right, the numbers are really mind-boggling. You can look at this number worldwide. The revenue that AI has generated is close to 327 billions. If you look at just in 2020, the funding that AI startups has got is in range of 38 billion. And this is just in first 6 months of 2021, right? If you look at other numbers where how much impact AI can have on your top line, almost 6.3% is contributed to AI-driven solutions that are deployed in the organizations. And if we go by some of the other research from one of the leading consulting firm, the potential value that AI is gonna deliver is close to 5.8 trillion. So still we are yet to fill that gap from 327 billion to 5.8 trillion. So that's the potential AI has to generate value across the different industries and sectors. But if we look at AI, right, AI is not this decade's baby, right? It has its root way back in 1950s when first Alan Turing proposed or submitted his paper on computing machinery and intelligence. And he asked a very basic question, can machine think? And that is how there is a lot of research started in the field of AI. And it was 1957 when John McCarthy first proposed this term or coined this term as artificial intelligence. After that, AI has seen many burst and boom cycles. So it has its peak time where researchers made a big breakthrough into AI, but again, it was followed by some AI winters where the funding was shrunk and there couldn't happen much in terms of the actual application of AI. So this continued for initial 40 years, but it was 1990s or late 80s when there was a major breakthrough happened. I mean, something happened that brought AI into action. I think it was the advances into the computing power of computers, right? The Moore's law has kicked in, the computing power was getting cheaper and computers were getting faster. At the same time, storage was getting cheaper. And that is when some of the research that was already done in AI got into action. And that is how AI and computing have very close relation and always discussed in conjunction. Because some of the advancements that happened in the field of AI, specifically in terms of the deep neural network algorithms, they were data hungry, they were compute intensive, and there were limitations in terms of having that kind of computing power during that time. And when this breakthrough happened in the field of computing, it propelled this adoption of AI into mainstream business. And that is where we saw in 1997 AI could, or supercomputers is what we used to call, defeated one of the masters in the field of chess. And that is where some of the traditional ML practices started getting into business. Predictive analytics was, one of the practice which was statistical driven, but it found its place in business application. It was this decade of 2020s when AI got a couple of breakthroughs. We all know it was September 2012 when AlexNet, one of the deep neural network, defeated the traditional network in the ImageNet competition by hopping 10.8% accuracy. Followed by that, we saw in 2017, AlphaGo, which is DeepMind's baby. It defeated one of the, that times or even today's, #1 Go player, Kijak. So I think these were the breakthroughs which got AI into, it created a hype and buzz around AI, but quickly enough, it found its place into business applications as well. So if we look at this 40, 60, 70 years of a journey from AI, it started as a field of research, but now has got into the business because there is enough power and storage available to support these compute intensive data hungry algorithms. And that's why we are going to see how cloud computing can help your AI journey, how it can accelerate adoption of AI for many of the newcome entrepreneurs or enterprises, as well as how some of the business leaders can make use of cloud computing to build their AI solutions. So this is the quick agenda. What we are going to do, we are going to look at cloud computing to start with. What is it? Some basics of cloud computing. Then we'll look at what is the AI solution life cycle? What are the different stages which are involved in AI application development life cycle, so that we can understand how cloud computing can help accelerate some of these stages so that your adoption of AI is really a reality. Then we are going to look at some of the deep learning services as well, which are available on cloud. And then we will see some of the industry use cases, how some of the players have in the industry, across the industries, have used AI to build cloud computing to build some of the AI solutions. And then on the closing note, we will just see where AI and cloud is heading and what we can expect in future from these two technologies. So cloud computing. Again, if I have to in traditional terms, if I have to define what is cloud computing is nothing but on-demand provisioning of computing resources over the internet with pay-as-you-go pricing. There are very key features that are listed here, and this is the definition that NIST publishes for the cloud computing. The first key element here is on-demand self-service. What does that mean? That you can now have access to different computing resources, be it compute, storage, networking, and so on, the IT resources, or as a self-serve model. You yourself can provision hardware that you need without even human intervention. So earlier, if you relate it to traditional way of provisioning IT infrastructure, you have to procure infrastructure, you have to take it to your data centers, and after that it was provisioned to the users, and it was a long cycle to meet. But now we can see cloud enables it just at your fingertips in within minutes, or rather in seconds, you can have the computing or IT resources that you need to build your application. So on-demand self-service is one of the features that makes cloud computing different from your traditional way of computing. Second, as we saw, broader network access. This is another feature where the resources have to be accessible from anywhere, not just from the network in which we have connected. In traditional way, all the computers were connected to data centers through a WAN or LAN, and that is how they used to access these computing resources. But now you can access any resource from anywhere with cloud computing. The third is on the resource pooling. What we are talking about here, that it's on demand. So whenever you need, you can get a computing or IT resources for your use. And that needs these IT resources to be pooled together. There have to be the cloud service provider have to pool all these computing resources or IT resources together to enable a real on-demand self-service. The next one is the rapid elasticity. This is one of the key features that makes cloud computing different from your traditional computing, where you can grow and shrink at your will. So whenever you need more resources, when you need scalability, you can get it at the fingertips, or there are even options available to auto scale. And at the same time, when there is no demand and when your demand slows down in a particular cycle, you can give these resources back to the cloud provider. So that elasticity has made cloud computing a game changer in terms of its utilization in overall computing. And finally, the measured services. This is one of the feature where all the services you use are metered. When I say metered, you pay as you use. So whatever you are paying, it's for whatever you are going to use. So it's not a fixed cost that is associated with these computing resources. What you do, you pay for only what you use. So I think that is how cloud computing is defined. It is on-demand provisioning of IT resources over internet with pay-as-you-go pricing. So that is how cloud computing is different from what we do in the traditional world. If we look at some of the cloud service providers who are available right now in the market, right? We all know the AWS, Azure, and Google are the major players, global major players in cloud service providers. And then Alibaba Cloud is also catching up ground. Specifically, it has started in Asia, majorly in China, but now it is also expanding its footprint at the places. So these are the four major players in the cloud service or in the cloud computing. There are many other players available, like we have Salesforce offers a cloud, IBM Cloud is there. There are a lot of other small players who offer a software as a service. They are also part of a cloud service providers. But why we are discussing these four? Because they cover major coverage across the markets and industries. If you look at AWS, covers 32% of a market share. Microsoft Azure, which occupies almost 20% of a market share in cloud computing. Google has 9% of share, and then Alibaba has 6% of share. When we talk about cloud computing, right? Cloud computing has four different ways of deploying a cloud. So the first one is a private cloud. Private cloud is nothing but it is dedicated to a specific user or users. So similar to on-premises, right? On-premises, when you have all the IT resources available in your own data centers. So private cloud is nothing but you may have your own on-premise data center, or you can have a vendor provided leased data center, but specific to your users. And on top of it, you put virtualization, and that is how you can get some of the features that cloud computing offers. So private cloud is nothing but a cloud computing offering which is specific to an end user. And it is earlier it was ran on the on-premise infrastructure, but now it has It can run on rented or leased vendor-owned data centers as well. The second deployment model in cloud is public cloud, and that is what we all know. Amazon, Azure, GCP, these are all public cloud offerings. What do? They have pool of resources, and all the resources are owned by now service providers and not by the organization owned or leased. And they pool these resources, and then they enable the provisioning over broad access network, as we talked about. And that is how they offer it in a self-service model with pay-as-you-go pricing. So here you need not to invest any uh, um, money to have a data center in place. What you can do, you can take these resources from the pool of resources. So that is the public cloud, what it offers. Then we have hybrid cloud offerings as well, because we know that there are large number of enterprises who already have their own data centers. So they can't really do away with their infrastructure. But what they are really looking for to make use of public cloud offering to complement their resources. So for example, they want to build an AI capability or AI platform which needs a lot of open source softwares, which might not be certified by their in-house security team. They might want to experiment, innovate, and that is where they want to make use of public cloud. And so when these kind of setup is needed, there is a hybrid cloud offering is available where you can uh, access public cloud from your private cloud, or not private cloud, but from on-premise infrastructure. And then you can bring them together to build a hybrid cloud. So hybrid is nothing but a private and public. You can access these two together. I think it is formally defined as well, where you can have one private and one public cloud, or you can have two or more private clouds or two or more public clouds from different vendors. And that is how you can define a hybrid cloud. What are the advantages? As I said, maybe you can complement your in-house infrastructure with some of the innovations which are happening in the public cloud area. Then there is something called as a community cloud as well, which is when a group of organizations come together to share their infrastructure. It is not widely adopted practice to have a community cloud. So majorly you will see a public cloud, hybrid cloud, or a private cloud offerings. So that is based on the deployment models that we have. If we move on, we also have something called as a different service models in which cloud computing is offered, or in which the resources, the IT resources that you need for your applications, for your solutions are offered. So there are primarily three service offerings or service models. And now as cloud computing is reaching to a mature stage, there will be more offerings available as well. So the first service model is infrastructure as a service. Infrastructure as a service, what it means, where infrastructure, which is your compute, storage, and networking, is offered to you as a basic building blocks. So these resources you can have from cloud service providers, and on top of you can have your own hardened OS images. You can build your applications. You can install your operating systems, runtimes, and then build your applications on top of it. So that is the infrastructure as a service. And we will look at some of the services which are available in each of these service providers, which belongs to this service model. The second offering or service model is platform as a service. What platform as a service does, it instead of just providing infrastructure to the end users and letting them taking care of operating system or middlewares or runtimes, what it does, it provides platform for you to build your application. So you need not to worry about what operating system to run, what middlewares to run, installing all the runtimes required for your application. Everything is offered you as a platform. You just deploy your application on that platform, and that's it. I think it takes away all the responsibilities from you in terms of managing the underlying infrastructure and the operating system and middleware and runtime. So that's a platform as a service. The third service model that we have in cloud computing is mostly on software as a service. What does software as a service means? Software as a service packages a software solution or application and offers you as a service. I think in the Indian context, we know one service provider. You might all know Zoho, which is a unicorn, a startup, a bootstrap startup. They offer a lot of services like CRM and your IT management and so on as a service. So they are also, that is also one of the offerings of cloud service model, which talks about software as a service. The cloud providers that we looked at, which are public cloud providers like AWS, Azure, and GCP, IBM Cloud, they also offer some of the software as a service, whatever services or applications you need to build your application. So we are going to look at some of these services in the following section. Okay, so that is on the service model. Are there any questions in section, or we are all good?
I think we are good for now.
Okay, thank you. So I don't see any questions, so I'll move on. Okay, so now we looked at, first of all, cloud computing, what it is, right? So it's nothing but on-demand provisioning of IT resources over internet with pay-as-you-go pricing model. We looked at some of the service models, like what cloud service providers really offer. They offer you infrastructure, underlying infrastructure as a service. They offer you platform as a service, and they also offer some of the softwares, bundled softwares for ready to use, which are the managed services, is what we call. We also looked at some of the deployment models, which are private, public, hybrid, and community. But why cloud computing is making a lot of sense nowadays? If you're from a startup background, you might know many of the startups have started as a cloud native. They build their enterprise, or they used all the IT resources ground up on the cloud itself. Also, there are major enterprises who have moved from their traditional on-premise infrastructure to cloud computing. We are going to look at that industry use case, which is a very well-known case of Netflix, which till 2008, they were using their own on-premise infrastructure. And that is when they started the whole migration to cloud, which finished in 2015, where they migrated all their services onto cloud and uses AWS for almost all their use cases. So what is it there for business leaders or the entrepreneurs which makes cloud computing so exciting for them? So definitely the first is the capex and cost saving. We all know that if you have to start a startup or any enterprise, or if you want to build a solution, what you need is capital expenditure. You have to come up with some fixed cost to buy IT resources so that you can start with building your application, right? But what cloud does, cloud takes away this capital expenditure from business leaders and from entrepreneurs and turn it into operational expenditures, because you need not to invest. You need not to have that initial heavy capital investment to start your business or to start your application. What you have to do as your organization matures, as you get more use cases, you can start using more resources, and you will pay only for what you use, right? So that's the reason there is a lot of I mean, this is one of the reasons why this is a very exciting part for major business leaders and entrepreneurs to start a cloud journey. The second is more on the innovation. We know innovation needs experimentation. You need to work with a lot of open source softwares or something which is in the beta version. And you do not want to compromise on the security of your organization's security. So you need an environment where you can experiment, you can try out new things, and you build the culture of innovation. And that is where cloud brings that whole gamut of all the resources and new softwares to you, where you can use it to build or experiment and come up with some of the innovative products. So that is another thing why cloud makes sense for a lot of business leaders and entrepreneurs. The third is accelerating time to market. We all know how critical it is to reduce this time to market. You want to, quickly deliver your applications, your changes to the market as early as possible. We all know before 2018 March, many of the retailers were brick and mortar retailers. They would have never thought of having an e-commerce arm. But when COVID hit, many of the users shifted to this online e-commerce or online shopping. And if you want to deliver something very quickly for these new digital native users, you have to make sure that you deliver your product or your application very quickly to these users. And that is what cloud computing offers. It accelerates the time to market, because you have access to the right resources at your fingertips. You can quickly experiment, you can build your MVP, and then you can deploy this application very quickly. You can make use of some of the cloud services to even open this product or application to global users. So this is something is very much possible just with cloud computing. In traditional way of operating, it's very impossible to reduce or accelerate the time to market. The final advantage that it offers for many is the agility and scale. As I said, in your initial days of building a product, you build your minimum viable product, you deliver it to the users, you are constantly taking the feedback and refining your product. When you need this kind of a agile environment to build your product, you also need your IT resources to be handled in a similar way. When you need something, you can get it at your fingertips, and that is what cloud computing offers you, the next level of agility in terms of building your applications. And the scale that we talked about. So for example, before pandemic, you are having a e-commerce website and that is having a X number of users. But when pandemic hit, I think these online shopping and online trend went on by 10x. So now you have more users to serve, and unless you have a scalable infrastructure at the underlying scalable infrastructure, you can't really cater to these needs of new users. And that is where when you need scale, cloud computing offers you that scale, a global scale where you can build your application, and they can scale they can auto scale, as well as you can make them scale as your user base grows. So you need not to worry about buying in more infrastructure, having downtimes to serve those new users, right? That is what cloud computing offers, the whole new level of agility and scale to your applications.
I think Abhijit, we have some questions in the Q&A.
Sure. Okay, I'll just pause and take some questions. Sure. So let me just. Yes, so I'll go in reverse order. So Shiv has asked how we can use AWS Cloud besides storing data. So I think data storage is one of the service that cloud offers. But along with the storage, it offers a lot other types of services. For example, it offers you compute. You can use some of the compute resources or compute services from AWS, GCP, Azure, and others. Then you can have AI services. You can have some of the managed services. Now they offer you serverless computing. So it's not just about storing data. That's just one small part of overall AWS offering. Along with that, it offers you compute, it offers you networking, it offers you new type of service. For example, for big data, it offers a lot of services to do big data analytics on cloud, where you can run your Hadoop clusters, Spark clusters. You can do visualization. They offer visualization services from the cloud, like AWS has Quick Insight, GCP has Looker, and Data Studio. So it's much more than storing data on cloud. And we are going to look at some of those services in following section. The second question that we have is, how does AI impact important customer metrics? And this is something that we are going to look in the following session. So I'll just park this question. If it is not answered, I'll take it in the question and answer session. But yes, we have seen very high number of adoptions of AI to boost the customer metrics in terms of customer acquisition, in terms of customer retention, overall improving the whole experience for customers. One of the simple use cases is chatbots, the conversational chatbots. I'm sure as a users, you might have seen, now chatbots are everywhere. When you have your first conversation, it's not with a human, it's with a bot. And the AI is helping organizations to improve the customer experience, where customers have that 24/7 support available. It is also improves your overall shopping experience. Say, for example, when you are interacting with the chatbot, it can help you to understand customer behavior and recommend right products. So we are going to look at some of these use cases in the following section. If it is not answered, feel free to raise it again in the question and answer session. The next one is, how can we differentiate data at scale from your data sharing up, data starting up? I didn't get it completely. So what we can do, we can park this question and maybe we can take this up in the Q&A session. What are the examples of PaaS? Sure. So if you go on AWS, suppose you want an environment just to deploy your application. So for example, GCP offers you something called as they have different types of computes which you can leverage to deploy your application. So you need not to first take the infrastructure, then put operating system on it, then put your runtimes on it, and then deploy your application. I think GCP, AWS both offers you environments to to deploy your application. GKE, the Google Kubernetes Engine, is one of the PaaS offering that they have. On AWS, you can have EKS, which is a Elastic Kubernetes engine. They have also ECS, which is Elastic Content Registry, where you can you can containerize your applications and just deploy them. You need not to take care of underlying OS and runtimes and so on. So we'll look at some of those use cases in a following section as well. Okay. So Lambda is in between PaaS and SaaS, you can say. It's basically it's a serverless, right? So that's what we are saying. Traditionally, we just have three types of classification. We said infrastructure as a service, we said platform as a service, and then we said managed service, which is infrastructure, software as a service. I think Lambda is a serverless, and you're correct. It's in between PaaS and SaaS is what we can say. Okay. So I'll continue. We have taken the questions. If there are any further questions, we can take them up in the Q&A session. So I'll continue. So there are a lot of questions because I think many of the folks have some background on the cloud, and that is where we are going to look at some of the services which are available from the cloud service providers. So there are many different buckets in which cloud service providers offers you different types of services. I have taken 6 buckets which are very relevant for our today's conversation, and we will just look at those, and there are many more that we can see if we can cover in later sections. So the first thing that we have is the compute, where the cloud service providers offers you different virtual machines or instances. They offer you container services. Containerization is nothing but one way of virtualizing your application. So they offer containerized services. In terms of AI, now cloud service providers have started offering you GPUs, TPUs. GPU is nothing but a graphical processing unit, and TPUs are TensorFlow processing units. They also offer you serverless computing. So there was a question on Lambda, and there are cloud functions from GCP. These are all examples of serverless computing, where you don't actually know where is. I mean, it can scale at any level where you need not your function or code is not bound to a server, but it can execute on a serverless computing mode. If we look at some of the computing services that are offered by different cloud service providers, from AWS, we have EC2, which is elastic compute machines that that are available. We have GCP offers GCP Compute or Google Compute. Under that, they offers you compute VMs. They offer you different types of VMs as well, preemptive VMs and standard VMs, and some platform as a service VMs as well. Azure offers similar type of services. Azure VM is typically is what they offer as a part of compute. Then there are other types of services which are around containerization. AWS offers you EKS, which is Elastic Kubernetes Service. We have GKE, which is Google Kubernetes Engine, available from GCP, which is also offers you a compute service where you can run your programs, your applications, and so on. The second class of service offering is on the storage. Under storage, what cloud service providers offers is place to store your data. So typically they started with object storage services. We have Azure Blob, which is from Azure to store the binary of large object data. We have Amazon S3, which is simple storage service from AWS. We have GCP offering you Google Storage, which is also object storage. These cloud storage providers, cloud service providers also offer you 5 storages, which you can use. They also offer you local SSDs, which can be attached to your specific compute instances so that you have very quick access to the data. So these different storage services are used in conjunction. Basis your need, you might have smaller local SSD for a quick access to your application, and then you can use object storage to keep your large volume of data on cloud. So then we have something called as archival storage. What you can do, you can set up object life cycles where for a lot of organization, because of regulatory reasons, they have to maintain say 7 years of a data. So what they can do without spending on keeping this unnecessary data on their active cloud storage, or we call it hot layer, what they can do, they can set up an archival strategy, or they can move these data sets to less expensive cold layers, like there is a near line and cold line on GCP. AWS also offers infrequent access storage class. So what you can do, you can also optimize your class cost by leveraging different storage options available for you on cloud. Then they also offer some of the services to manage your cloud infrastructure. Definitely, you need identity management where you take care of your authentication and authorization for your cloud resources. You also have to make sure that you have right security measures in place. You want to build networks, your virtual private networks or your virtual private cloud, which is nothing but setting up your network within your cloud subscription to put firewall in between your networks, segregate the workloads so that they don't interact with each other. Basis your requirement. They also offer some of these services on content delivery, the CDNs, content delivery network, where you can keep your data and content close to the users from where they are accessing. So I think these are some of the management services offered by different cloud service providers. AWS have IAM, which is Access Identity and Access Management. GCP also have IAM, which is access identity and access management. Azure comes with their access management tool. Then they offer VPCs and similar services for networking, and CDN for content delivery. The next set of services that cloud offers that we talked about for big data analytics under analytics umbrella. So nowadays there is a lot of adoption of big data computing, and you might need to run your Hadoop infrastructure, or you want to leverage Spark for your large scale computing. You want to take advantage of some of the new age massively parallel processing data engines like Redshifts, and Azure offers you Azure DWH, Azure Data Warehouse, or Azure Synapse. Also, GCP offers you BigQuery. These are some of the services which enables big data analytics. We all know that data has exploded in last couple of decades, and it's all about deriving right insights from this data, and that is where these services come into picture, where you can refine this data, distill this data, and take out the insights which are actionable insights which matters to your business. So that is all. That is what all big data analytics does, and these are the services that are offered by different cloud providers. Then the traditional business intelligence, where you want to build your reports, you want relational databases, and that is what is also cloud computing or cloud service providers offers. Some of the services on business intelligence, Azure offers Power BI as the service from Azure infrastructure. You have something called as Looker and Data Studio on GCP. You have Quick Insight from AWS that you can use for business intelligence. You can use some of the relational databases which are available to store your data. So AWS offers you AWS RDS, AWS Aurora, and also Redshift is used to back a lot of front-end business intelligence solutions. When we go to GCP, GCP also offers, as I said, BigQuery that can store large volume of data and enable pulling insights at a fraction of a second from the business intelligence reports. Then they also offer search services. You want to enable search, want to build product catalogs that can enable quick search functionalities for users. So under analytics, AWS offers, now they have something called as a Kendra, AWS Kendra. Earlier, they also offered Elasticsearch as a managed Elasticsearch service from AWS. GCP also offers their wrapper around Elasticsearch. So these are some of the services which are available under analytics umbrella. Then when we look at AI and ML, I think this is the area where cloud has really made a significant progress. And we have a lot of services available in AI and ML space. We are going to look at those services, so I'll not go into the details. And some of the cutting edge technologies like blockchain, quantum computing, IoTs, Internet of Things. Nowadays, manufacturing is delivering a lot of sensors, and cloud service providers offers you services to connect your IoT devices to cloud and do analytics on top of it. Let's quickly look at the life cycle of AI solutions. Before even the technical life cycle starts, the first stage is a problem formulation. So where the business users and topic experts form a problem to be solved, and thereafter the AI solution life cycle kicks in. It starts with exploratory data analysis, where data scientists spend time understanding the data, uncovering the trends, understanding some of the patterns, identifying some of the quality issues, and so on. In traditional world, you used to do univariate analysis, bivariate analysis. In terms of machine learning algorithms, you further want to explore the data and see what all features really make sense for your model. The second phase is more on the pre-processing. You can't feed raw data as it is to your models. So you need to clean this data. You have to impute data wherever data is not available. you have to prepare data, you have to do feature engineering, which includes feature selection, feature elimination, and so on. So all these tasks are part of a pre-processing. When we are looking at some of the deep learning or models, then pre-processing might differ. You want to make sure that all your images are clipped, they are all cropped, they are brought to a standard size, they are converted into byte arrays before they are fed to your model. So that kind of pre-processing can happen for some of the different types of solution. Similarly, if you have an NLP solution to be built, it could be tokenization of text data, lemmatization, and so on could be part of your pre-processing. The next phase is on training your models, where once you have developed your models, you want to train them on the trained data, then you want to evaluate its performance, and then you want to tune your models further. So something that we all refer as a hyperparameter tuning kicks in, where you want to, and this is an iterative process where you keep on refining your models until you get expected results from your model. And once you get the expected models, once you test the effectiveness of your models, that is the time when you go for deploying these models. So next set of services that you need are to deploying these models and serving these models. Serving is nothing but how these models can be integrated into your business process. So there are different ways of serving these models. It could be batch-based modeling, where your models are running on batch set of data and then identifying some anomalies or identifying or predicting the values. The other could be real time. In real time, say for example, when you do a transaction, it will predict basis the transaction done. And third is at the age, where now age is catching up, where you want everything to be done at age, and that is how the age serving model can be used. The last phase in your AI solution building is more on monitoring your models, because your models drift, they decay. And that is where you want to monitor their performance. And as they decay over a period of time, you want to improve them. And that's the final stage in your AI life cycle. There is a kind of a loop from monitor to improvise, and then it will kickstart the pre-processing, train, deploy, serve, and this cycle will keep on going on. Now we looked at cloud computing. What is cloud computing? What are some of the services that it offers? We looked at different stages of AI applications, right? Now let's look at the core of our subject, that how cloud computing can help accelerate AI solutions. So as we looked at, the first stage in building AI solution is all about data exploration, preparation, feature engineering, and so on, right? This is the stage where you spend a lot of time in terms of making sure you have right data, because for like other applications, for machine learning as well, the concept seems to, which is garbage in, garbage out. So if you don't have right data available, your model is not going to function properly. And that is where so the cloud computing comes to a rescue. The GCP or Google Cloud Services offer two services which are very intelligent, or one service which is very intelligent service, which is data prep. What it can do when you are doing data exploration and preparation, first of all, it is serverless. So you need not to worry about installing something, making sure that you have right compute to explore your data, you have right size cluster and so on. So it totally serverless, takes away all these complexities from you. It has functionality to predict transformation. So it looks at your data and it proposes what type of transformations are necessary on those data set. It also identify anomalies in terms of null values, the missing values, values which are not conforming to the expected values. And it suggests you what kind of transformations are required on these kind of data sets. And it also triggers a fast exploration. For example, Google Data Prep can generate these summary statistics just at our fingertips. So you just click and you get the summary statistic. It's that quick. How does these services help? Google Data Prep, they takes away your focus from doing manual and time-consuming activities and focus on your ML solution building. And that is when this cloud comes handy, where they can really accelerate your data preparation feature engineering part. The other services are Google Dataflow and AWS Batch. What they can do, say, for example, you are building a deep learning model and you have millions of images to process and fed to your model. Now, if you do it with a traditional way or on a even single virtual machines which are advanced enough to handle large volume, it will take days to finish the processing on this data set. What Dataflow and Batch offers you is a fully managed, infinitely scalable infrastructure on which you can run your data preparation or even model training components. So these are some of the services which can come really handy when you want to accelerate your data preparation stage of AI solution building. The next is, once you have data ready, what you want to do is you want to train your models. And if we look at the deep learning models or DNNs, you need very sophisticated and advanced infrastructure to support training your data and then running your models. If you have, just to highlight, when AlexNet came first in 2012 in that ImageNet competition, what enabled AlexNet to perform so good is the underlying GPU. It was trained and built on GPUs, which enabled it to make these fast decisions. So when you need to build and develop or train your models, you need very advanced, sophisticated hardware. And that is where cloud comes very handy. GCP Deep Learning VM is a kind of a compute machine that you can roll out just in few minutes. You can just click on deploy and GCP within few minutes set up a deep learning VM for you. It has all these packages installed, pre-installed for your ready use. So you can use, you have all the scikit-learn, TensorFlow, PyTorch, Chainer, and Rapids. All these packages are pre-installed. So you need not to worry about the incompatibility or any other challenges in deploying these packages. Then they offer you to have TPUs and GPUs for these VMs. So once you develop your model and when you want to train your models, the GCP Deep Learning VM offers you TPUs and GPUs for the same VM, and you can use them to train your models. Similarly, AWS offers you deep learning AMIs. AMI is nothing but a AWS machine image. And in addition to all the these packages, common packages that you see on top, it also offers you some of the additional packages to run your or to train your machine learning models. It also supports GPUs offered from NVIDIA. So you can train your deep learning models very quickly. Similarly, Azure offers Azure Data Science VM. Azure has two options, Windows as well as Ubuntu. And what it does, along with all these environments, it also offers these new set of tools like, say, MLflow, which is used to do ML ops, to manage your ML lifecycle. It offers you Power BI to quickly visualize output of your model, just to see what is the accuracy, what is the recall, just to measure the performance of your model. It offers you Spark bundled, where you can make use of distributed computing to do some of the pre-processing. So all these benefits comes bundled in a virtual machine that you can deploy at within just few minutes and get going. So I think this is one of the ways cloud helps accelerate your AI development cycle by offering you right environments to build, train, and evaluate your models. The next, which is quite an advancement that cloud offers, and not just cloud, AutoML is the new emerging topic nowadays. What AutoML is doing now, even you need not to develop your machine learning models. The AutoML offers, or it is a emerging technology that automates your machine learning task, and it accelerates your model building process significantly, so that you need not to worry about training your models and doing hyperparameter tuning, the iterative process that we talked about, right, in our AI software lifecycle. You need not to focus on this. What you can focus on, how you can improve your machine learning models, how you can make it relevant for your domain. That is what you can focus on, and that is whole AutoML is offering. Google has already, the cloud service providers are already built services on top of AutoML. Google offers you Google Vertex AI. Traditionally, it was they used to offer two services, AI platform and Google AutoML. Now they have combined it to offer you as a one bundle, Google Vertex AI. There is one more player, which is a software as a service, Data Robot. They offer you this whole AutoML platform as a service, as a software through cloud. The AWS SageMaker also makes it possible in conjunction with AutoGlucon. So you can use AWS SageMaker with AutoGlucon to create your models. So here you are not training your models, you are not developing any code. Even without developing any code, these models can develop your code, develop your models. So what you have to do, so for example, you are building an image classification model. Now you need not to develop a machine learning model, but rather you have to have a smaller data set of a input data set where you tag these images to as per your domain. And then you feed this data to the services. The services look at the data, the labels, they pick the right model to be used, be it a CNN or any other deep learning model, and then basis that they do a hyperparameter tuning, they improve the accuracy, and that is how the trained model is offered to you. So it really takes away all the efforts on building and training and hyper or tuning your models from data scientists, and do it for you. There are some stats on how AutoML have helped some of the industry players. We can say that it offers 10x acceleration for building, tuning, and deploying your models. So that's very significant. When you really want to quickly make use of the time to market acceleration that we talked about, right? The AutoML just is one example of how cloud can help you accelerate your time to market. In terms of accuracy as well, there are stats that earlier they were having 80% of accuracy, but these auto-trained models help to improve that accuracy further sorry, to 87.5, which is 7.5% of a gain. Similarly, PayPal has used AutoML for fraud detection, and their model has shown a significant improvement. And now it can predict or detect the frauds at 94.7% of accuracy. So this is the acceleration that AutoML offers you. What it also does, it is democratizing this AI skills. So we all know the AI is a niche skill, but at the same time, so it is one of the deterrent for organizations to adopt machine learning or AI. But AutoML, if you have right domain knowledge and a good foundational knowledge about machine learning, you can make use of AutoML to build your models. So that is truly possible with cloud and some of the advancement into AutoML. AutoML also, there are open source packages are also available on AutoML. But when you go to cloud, you get the entire ecosystem around it, and that really helps to accelerate your model building time. These are some of the cloud computing services that we have for deep learning. I have specifically chosen GCP and AWS, but there are many other players which offer you cloud services for deep learning. we know how difficult it is to train your models for speech to text, especially if you need a multilingual support. Similarly, the whole OCR part, where you have to fed in the text captured in images or PDFs, and you want to extract the data, it is also a time-consuming activity. We need support to um, classify images and all computer vision. It is also a very complicated and complex subject in itself. What cloud has done really good is they have used their own learning in AI and machine learning to offer you some of these services that you can use for get your work done. So now, if you want to translate something from one language to other, instead of building your own NLP model, going through that entire cycle and training your models, you can use the service which is already available. So that really accelerates your, not just accelerate your solution building process, but also gives you access to the years of investment and innovation that these organizations have done for themselves. So we know how better Google works and how well Amazon is, doing some of the things like recommendations and translations and all that Amazon Alexa thing, how easily it understands what you are saying and can cater to your voice-based requests. So these services gives you access to that experience and knowledge and the expertise that these cloud service providers have built. And I think so we are going to look at some of the services, how different industry players have built some of these solutions using these services. So I'll just move on. Jatin, are there any questions in Q&A that we can take, or?
I think we have a lot of questions, so now we have 6 to 7 questions. So maybe in the end we can take it. We have only 20 minutes.
Okay. So now we looked at some of the services that cloud service providers offers. Now let's look at how these services can be used to build real AI applications. So we talked about improving customer experience, right? And conversational chatbots plays a very important role in improving overall customer satisfaction. Now, building a chatbot or conversational chatbot is very challenging task. You need to, what you need is a natural language understanding, first of all, a model that is trained for natural language understanding, where it can understand what an end user is saying, in what language it is saying. Then it needs the ability to understand the intent of that request. You need to make sure that you maintain the state and context through the different services. Because when I start a conversation, I will keep on putting the requests. Like I'll start with, where is my order? And it will ask me to put in an order number. Once I give you an order number, my next conversation is about that order. So the chatbot needs to maintain the context throughout the conversation. It should feel like conversation for the end users. And that is where Google Dialogflow and Amazon Lex, these services come into picture, where Google Dialogflow and Lex both offers pre-trained models to start with for a particular domain. So for example, you are into a food ordering startup and you need to build a chatbot to take orders or maybe to answer some of the queries from your customers. What you can do, even without training, you can take the pre-trained NLU unit and then customize it according to your needs and then quickly deploy this chatbot for real use. It also offers you integration with other cloud services. Like say, for example, NLU is one part of a chatbot. You also need integration with other channels. And these tools allow you to integrate your chatbot with, say, Facebook Messenger, with Slack, and some other chatting platforms as well, so that you can Once you integrate, it's like front end is Facebook Messenger or Slack, and then back end is your chatbot, right? So how it is that easy to build your chatbots. Google Dialogflow also offers you to build your chatbot within just few minutes. Your fact-based, the frequently asked question-based um, chatbot you can just have your facts, you can upload it on Google Dialogflow. It will train its model on its own, and it will let you to use that model to build your chatbot. And it also offers you a preview functionality where you can see how this chatbot is going to behave. You can actually put your request and see how this chatbot is going to respond to the request. Once you are comfortable, you can deploy that in for a real use. We call it go live. So it is that easy to build conversational chatbots using Dialogflow and Lex. There are some of the open source packages are also available, but what cloud helps is again the ecosystem, the integration that you need. You need to pull out databases basis of users request. So Google Dialogflow offers integration with your Google databases where you are running somewhere on Google, say Google Firestore or somewhere else. You can access that data. You might need to do some computations or translations or processing. That is where Google Cloud functions come into a picture. Something like AWS Lambda, where you can make use of these cloud functions to run your code snippets and then create your response for the users. So this ecosystem of services helps you really build your applications just within few days, if it's not just within few minutes. So I think it's that quick to build conversational chatbot using some of these services. We all know, if we the Amazon openly says the close to 32% of their revenue is from product recommendations. And for a $1 billion company or a company with $1 billion of a revenue, 32% is quite a huge number. So that is the power of recommendation engines. Now, what Amazon Personalize and Google Recommendation AI has done, they have created service on top of it. So you need not to worry about how to build your how to do matrix factorization, how to build a recommender system, how to tune it, also how to go beyond traditional way of building a collaborative filtering based recommendation engine, right? And really use some of the deep learning models to build your recommendation engines. So what these two players have done, they have build two services which you can use to build a product recommendation engine, where what you have to do, you just need to fed data in a standard form to these services. These services will understand the data. They will come up with the recommendations. They will also, once you can also have a feedback loop where basis how those recommendations are working, they can keep changing themselves and get better at it. And that is the power that Amazon Personalized and Google Recommendation AI offers. There are already adoption of these services into mainstream business, and a lot of retailers and other players have built product recommendation engines using these offerings. And we are going to look at those players in industry use cases. The third specific out-of-the-box AI service that a cloud offers is more on the forecasting. You know that for supply chain efficiency, it's very important to have right forecast. And traditionally, organizations have been using something like Arima, Sarima, Prophet kind of models to predict the sales volume or your inventory needs. And basis the demand, they decide how much to procure, right? So forecasting plays a key role in fine-tuning your business and your supply chain. Now, what Amazon Forecast offers, it again takes in predefined data set, standard data set as an input. It can again look at the different models available, and it can pick a best model to satisfy or to forecast the demand for the given use case. So it will look at your data, it will see, which model is performing better. It will benchmark those models in itself, and then it will choose one model that can be deployed for your application. So again, this is out of box AI. You need not to code, you need not to develop anything. You can make use of this service to really build a forecasting model out of the box. And that really accelerate your process. If, for example, you are getting out of a pandemic, and then you want to make sure that you have a right prediction of your demand, you can build a forecasting application very quickly to see how it's going to look like, and accordingly fine tune your supply chain. There are cases where you need custom solutions. Say, for example, when pandemic hit, your forecasting models really didn't work, right? Because they were built on certain historical patterns, and those patterns were not there at all in the new world when everyone was at home and were mostly on the online mediums. So that is where you need custom solution, and that is where the customization comes into play. But barring those use cases, when you have to have a standardized solution, I think the services like Amazon Forecast can really comes to your rescue to accelerate the whole AI building power. In interest of time, let's quickly go through some of the industry use cases, how industry has adopted some of these services to accelerate their AI adoption. We all know Ant Group is one of the largest group in China, and Ant Financial is truly a cloud native organization built on Alibaba Cloud. They have leveraged AI in all their application, be it automatically setting credit limits, deciding interest rate, identifying the credit risk profile, and so on. They very proudly market their 301 model, where they say it takes only 3 minutes to apply, 0 minutes to approve, and 1 minute to disperse the loan. That is kind of a confidence these organizations have because of the advantage that they have got being on a cloud computing and leveraging artificial intelligence in all their processes. Similarly, we know Netflix started way back in 2008 to move to their AWS, and now they serve this global user base through their AWS infrastructure. Without having that scale, it wouldn't have been possible to penetrate into new markets, to have content very close to the end users in countries like India or Sri Lanka. So I think the cloud has really helped them to cope up with the new scale that they have achieved over a period of time. Some of the other use cases. So just to improve the customer engagement and deliver larger impact, the Ole, the PNG group, build a skin advisor. So what it does, again, it is an AI-powered skincare advisor, where you just go on their skincare on this advisor, you click your selfie, and the computer vision kicks in. The models which are trained, they look at the different parts of your face, and basis that it recommends you a right product. It also predicts the age of your skin age, and then it decides what is the right product for your skin. And Ole has really doubled their conversion rates with AI-powered skincare advisor. So the question that we have, that how AI impacts the customer metrics. I think one of the metrics is conversion rate, right? For your customer, how do you convert the leads that you get into a final purchase? And here is the example where Ole says that they have doubled their conversion rates with help of the skincare advisor. It is installed in their stores, as well as it is available online. If we look at some of the services that we looked at, so the Amazon recognition, which is one of the computer vision service, it allows you to predict the age of skin age of a person. So it acts in similar way. So if you have to build a similar kind of a solution, what you simply do is, you need to capture that image and then use this API to understand age of the skin age of this person, and basis that it can recommend some of the products for the end user. We all know IKEA. I think IKEA retail has increased their overall order value for e-commerce by 2% using recommendations AI service from Google. So, when you go to IKEA app or web app, the basis you're browsing, it shows you related products. And I'm not sure if you have used this app or not, but when I'm doing shopping, when I pick a bed, it shows me which are the right mattresses for that bed, for the size, basis the the kind of bed I have selected, if it's for kid versus adult and so on. So it is these, and it makes me so easy to put that product into cart, right? Because you are seeing the right products. You need not to scan through thousands or millions of projects which are available on the portal and then find the right one for your shopping. So this is how recommendations AI has quickly accelerated their journey to build a recommendation system, and that is how it has helped IKEA to improve their order value by 2%, which is really significant. In Indian context, we talked about the forecast service, right? So more retail has moved from their traditional forecasting method to AI-based Amazon forecast service, and they quote in quote that they have seen improvement from 27% to 76%. That's a huge accuracy improvement that more has gained, and that is how they can make use of this to lower their food wastage or fresh wastage by 20%. So we all know the fresh category or fresh produce category for retailers is a perishable category, and they have to make sure that they have to ensure the freshness of their food or produce. At the same time, they have to make sure that they are selling. There is a high turnover for their fresh produce items, and they minimize the wastage so that the wastage is lost sale and lost revenue. So that is how they made use of Amazon forecast to understand what would be the demand in coming days. And this tuned demand helped them to lower their wastage by 20%, which is again a significant achievement using a AI-backed model. There are a lot of details also available on what model was used and how Amazon forecast made use of deep AR plus model to forecast the demand for more. I'll just take a pause. We are running behind the time, but let me see if there are any relevant questions.
So we have questions, Abhijit. I will read out them for you. So Manish has asked, Amazon forecast can be used in other forecasting models besides sales and supply chain. Do AWS offer services which can be used for forecasting a business model in pharma sector, especially drug sales forecasting?
Yes, so it's not very specific to sales and supply chain. Even you can forecast the user presence. Say, for example, you are building a social network. You have some data in terms of what is the user engagement that you see on your app, and you really want to predict that how it's gonna look like. You can even make use of forecast to do that. Same is possible for pharma as well, as long as you have right history available with you, because the forecasting models make use of historical data, and the more the better. If you have those data sets, then you make use of those data sets and build their models, tune them, and then you can make use of them to forecast your sales or your distributions or your inventory as well. So yes, I think it has applications outside sales and supply chain. It can be used for many other use cases as well.
Okay, he has a second question also. Is RapidMiner tool is also part of AutoML?
To be honest, I haven't worked with RapidMiner since long. It was 5 years back I used RapidMiner. I really don't recall how it acts, but I know Data Robot, Data IQ, these are the new age products. They definitely deploy AutoML. So AutoML is nothing but you need not to write any code to build your model. So for example, if you are using Data Robot, what it does, You feed in your data. It also allows you to clean your data, prepare your data without writing single line of a code. And once you are done with that, what it does, it makes use of a right model as per your need. So it runs maybe 5-7 different iterations. It tunes those models and then it picks the right one for you. So I think whatever tool offers these kind of functionalities really offering you AutoML. I'm not specifically sure about RapidMiner, but I'll see and I'll let Jatin know, and then he can pass on that message to the user. Okay.
Sure. Next question we have is Alexa built by using cloud computing, and which AWS services were used to build in that case?
I'm not sure that information is available in the public domain that how AWS build Alexa, but what Amazon guarantees you that the skills that it used to train Alexa are available with their services like Amazon Translation or Amazon Poly. So these are the services make use of similar technologies that are used to build Alexa. See, when it comes to deep learning or text to speech, voice to speech, voice to text kind of use cases, the challenge is having a huge volume of data, right? The more you have to train your model, the better results it will produce. Same holds true with vision APIs as well. So Amazon and Google had that leverage where they already had access to large volume of data, and that is how they have already trained their models. So for example, when you do that I'm not a robot check, where it asks you in which images you see a bicycle or a motor or something, it is a way Google is training their models, and in a way it uses that information to further improve their models, and that is what it offers you through Google Vision APIs. So I'm not sure about what all technologies are used to build Alexa, but what I know for sure that the knowledge and the experience that Amazon got while building Alexa, the same level of a translation model is available to us with Amazon Translation, Amazon Poly services.
Okay, thank you. Next question is by Ravi. Between Google Cloud Platform, Azure, and AWS model development, which one is better? Also, Azure is offering services like Power BI and SQL Server. Do AWS have some visualization tool which they offer?
Yeah, so I'll take the later part first. Yes, AWS has it offers QuickSight as one of the visualization tool, which is a managed service that it offers for visualizing different data set. In terms of which one is better, right? For model development, I think developing model you can develop anywhere, right? Even on your local machines. Where you face challenges is in terms of first training, because some of the deep learning models need sophisticated, advanced hardware to train those models. You might need a data preparation part before training your models, where you need to make use of some of the services that cloud service providers offers, like data prep, where it is intelligent enough to identify some of the anomalies and recommend you some of the transformations that you should do. So in terms of model development, I think you can do it without even cloud, but the whole advantage you get is with the model training, evaluation, preparation, all these stages, right? Where you need compute, you need sophisticated hardware and so on. In between GCP, Azure, and AWS, I think there is no black and white answer for this. The things are gray. It depends on your use cases. Like some of the retailers are little hesitant to go on AWS, so they can make use of GCP or Azure. Some of the blue chips on Azure, so they prefer Azure because they are strategic alliance with Microsoft. GCP is something which offers a lot of services, and specifically pharma healthcare is very heavily dependent on GCP. So it depends on your use cases. I have seen use cases where people are using hybrid models. Say, for example, even it's possible that for
your recommendation engine, you are using Amazon Personalize, and for your image classification problem, you are using Google Vision. So even those kind of approaches are possible. So because we have that liberty to choose what works best for our use case, I think you can cherry pick and even go into a multi-cloud model and have your use cases across the clouds as well. So what you should do while assessing which cloud to go for, assess your internal needs, your strategic analysis, see where you are getting cost-effective solutions. Are there any trade-offs that you can make? Say, for example, GCP Vision is very effective in terms of classifying images, but maybe a little costlier. You can go for AWS with little cost-effective service at a compromised accuracy. So even that is possible. So you can assess what works best for you, and then you can take a call which one to go for.
Okay, so maybe the last question that we can take is by Nagin Kumar Singh. As I know, cloud is server.
Okay, so I'll go to the next question. As I know, cloud is a server-based system, but how they provide serverless computing? That's correct. At the end, right, there is a infrastructure, there is underlying infrastructure. So it's not really serverless as in without servers or without computing. Underlying, there is a grid of computers and the CPUs which are on which your code is going to run. By serverless, what do they mean? You might have seen in infrastructure as a service or platform as a service, you are running your code on specific virtual machines were allocated to you. So you can't go beyond that. In true serverless sense, it is all transparent to you. You don't know where it is running. If you are running 10,000 API calls today, you are catering to 1,000 requests versus 10,000 requests, you need not to know where it is running. You need not to know that, how it will scale up. The AWS GCP takes care of scaling and, providing you that infrastructure. So serverless is not, in literal meaning, it is not without a server. It's just that you're not running on specific server. It is transparent to you. So you don't see that underlying infrastructure where your code is running. Then I think we have.
I think you can take this question.
Please elaborate more on identity and access management and difference between what offered by GCP and AWS service. Okay, so I think there is no difference in terms of functionality. So at the end, identity and access management is how users should be authenticated and how you should be granted access to your cloud resources. So they follow similar models in terms of AWS have IAM and GCP, their services have the same name. So it's all about creating roles, giving role-based authorization. Then they offer a hierarchy of resources. AWS follows, they have a service called as AWS organization where you can hierarchically organize your resources, whereas GCP has a different way of organizing your resources. So it has a concept of organization, folders, and projects. That is how your resources are grouped. Whereas on AWS, you have organization, then you have your accounts, and in those accounts, your resources are grouped. When it comes to identity, Google uses different types of identities, like your Google ID or Google account is one of the identifier. So it need not to have a different identifier. It allows you to integrate your authentication with your organization's authentication system. Say, for example, my organization, suppose it already has Microsoft Active Directory based authentication, then it allows both AWS and GCP allows you to make use of those services first to authenticate the users. So once your internal system authenticates the user, then this authentication is integrated into AWS and GCP to grant the authorization. So that is how they're different. It's not offering wise, they don't have major difference in terms of identity and access management as such. I think we'll just pause. Let's cover the next part very quickly. I think we are, almost at the wrap, and then we will go into question and answer session.
Sure.
What next for AI and cloud? I'm sure many of you might have seen this video before. This really excites me, and then I just want to play it for all who is still with us. I'm not sure whether you're able to hear it, but at least you can see. It's refreshing, right, Jatin? You can see it on the screen.
Yes, I can see.
Jatin, am I audible?
Yes, you are audible. Can you hear me?
Hello. Am I audible, Jatin?
Yeah. Can you hear me?
Yeah, I can hear you now. Okay, so you might already be familiar with Boston Dynamics, right? It's one of the organizations which is into robotics, and very recently they published this video and made their Atlas, the new robo public. What it does, I think, what they call it is athletic intelligence. They're not literally using AI, artificial intelligence. It's more of a robotics, which is again part of AI, but more from the athletic intelligence perspective. But if we have to look at the future of AI, right, from where we can go now and what is the near-term future looking like, the first and foremost on everyone's mind is general intelligence, artificial general intelligence. So far, we have seen progress on computer vision, translation, now the athletic intelligence and so on. But the future is about the general intelligence, how robots or robotics can mimic, or computers can mimic the human intelligence as it is, not just in bits and pieces, but as a whole. So that is catching up. There is a lot of research going on in that direction. It may not happen very immediately, but it's very exciting to see how all these things are going to get tied together to make this artificial intelligence very close to human intelligence. Then we have all seen how autonomous mobile robots work. There are something called as the warehouse robots. I think in China there are very, very large warehouses which are run just by robots. So they have close to 4 men for I think some 200 square feet of square kilometers of a warehouse or a space, and they are making. There are only 4 people who are just monitoring these robots. The rest all is taken care by warehouse robots. So with this Industry 4.0 and adoption of Internet of Things, sensors, and so on, even in manufacturing, production, everywhere, every process is getting digitalized, and we will see, how the different systems will come together, how AI can play a role in it. For predictive maintenance, it's already a case where people are making use of AI to predict which machine or is going to get impacted, and they can take a predictive or precautionary measures to replace this component. We also see Edge AI. So far, we have seen whatever happens in cloud, right? But next is how we can run all these compute-intensive, data-heavy operations at the edge itself. So, for example, from where I'm accessing, we need not to send those data events to cloud where they will be processed and they will be predicted. Instead, we can make use of Edge AI, where at the edge locations itself, your models can run and they can answer some of the questions. Also, and this is the again where cloud and AI goes together, and you can, similar to edge computing, you can have something like a edge AI. If we'll very quickly look at the cloud computing, where it is heading, it's more towards edge computing. There is something called as a vertical cloud now. The government, for government, AWS earlier had a very specific catered offering for US government use cases. Now they are getting into vertical cloud, where they will carve out an area in this Google Cloud for a specific vertical. Say, for example, healthcare. They have very specific needs. They need sophistication. They have a lot of different regulations compared to non-healthcare industries like HIPAA and so on, right? So the next level is creating a vertical of a services which are catered to a specific industry. So that is catching up. There is a lot of new things happening in that world. Then overall, you might know that when we say that some of these cloud services pick the best model out of whatever models are already available, I think they are leveraging AI themselves for their cloud, for making their cloud services more effective. And this auto orchestration and optimization of cloud itself is gonna take will have a lot of focus in coming years, where cloud itself will use AI to optimize the services on its own. So for example, you run EC2 machine for your compute, and you are not switching it off. So it is running, but it's not getting utilized. Now cloud has that intelligence to see that you are not really making use of this machine, and it can auto terminate it, right? Basically, how you are using that machine. So auto orchestration and optimization is going to be a next thing in cloud computing as well. I think that's pretty much what I wanted to cover in this talk. I know it was a very lengthy conversation, but I hope I made justice to this topic. It's we know that AI and cloud are both very, very detailed subjects, and they need multiple sessions to cover all the details. But what I focused on is how we can make this conversation relevant for AI-based use cases using cloud computing. I think that's where I will pause, and I'll take questions. So
I think
if you have any,
Abhijit, we have one question which is pending. How does the AI impact important customer metrics?
Right. Yeah. So we cover that one part, right? How AI can help you in improving your customer engagement using chatbots. And that is where we also saw that how Oli leveraged it to improve their customer conversion rate by 2%. So that is one way AI can, improve your customer engagement. Other use case that we saw on recommendation engines. Recommendation engines or recommendation AI really helps your customers find the relevant products. At times, for you to have a right shopping experience as a shopper, you need right products in front of you, and that is what AI does. The recommendation AI that we saw for some of the retailers, where it really helped improve shopping experience for customer, and that not just delighted customer but also helped organization cross-sell and uplift their revenue. I hope that I answered that question, but if I didn't get the question correctly, you can correct me, and then I'm happy to take that question.
Sure, I think that's
Sure.
all we have for now. I think someone had asked, thank you so much for informative session. Can I get your mail ID to get more info about cloud service as my startup needed? So maybe he has provided his LinkedIn ID here, and you can contact him directly here, or maybe you can contact us. We will help you in getting the services that you need, or getting the questions that you need answered. So
Sure.
over to Arti.
Thanks.
Yep.
Thank you, Jatin. Yes, Abhijit, if it is okay with you, we can share your email ID with all the participants.
Yes.
And if you allow, we would be more than happy to share this presentation as well with them. Only the participants who attended.
Sure. The presentation part, I'll just confirm. What we can do, at least, I'm fine, sharing this LinkedIn profile ID with them.
Sure. Sure.
And I'm happy to, answer their queries, mentor them in whatever way I can. So that shouldn't be a problem at all.
Okay. Thank you, Abhijit. And yeah, with this, we've come to the end of the session. Thank you so much, Abhijit, for walking us through, not only through the basics of cloud computing, but also discussing the use cases where cloud computing is being very actively used and has created impact on the businesses of various giant corporates. Thank you so much, Abhijit, and thank you so much for sparing 90 minutes from your